Scalars, vectors, and coordinate systems. Like so many other things, physics needs a reference point. I know the title says scalars, vectors, and coordinate systems, but I'm going to actually hit these three items in backwards order. So first, coordinate systems. A coordinate system sets up a reference point as the origin, then defines things relative to that. So if I'm running a couple errands today and I want to map that out, I might set my home to be the origin. I might then describe my travel in terms of north, south, east, and west. Here's my home, and maybe the grocery store is 3 miles west of home. Here is 3 miles. The high school, it's kind of southeast of home. I'll need to go a half-mile east. It's about a half mile. And then a mile south. And that's where the high school is. The hospital, it's 4 miles north of me. I'm snapping all these locations to a coordinate system centered on my home. But this isn't great, right? There's enough stuff here to be able to do something, and it feels like I'm almost doing something. I'm just not quite doing it. So now I'm going to set up this system. What I would like to do is have the origin be my house, and I'm going to say any motion that goes from my home eastward, I'm going to call that motion along the positive x-axis. So I'm saying x with a hat over top to tell me the direction of x. So here is east. Any motion toward the east I'm going to count as positive x motion. So any motion toward the west then is negative x motion. I'm going to do the same thing with north-south. Any motion northward I'm going to call positive y motion. Any motion southward I'm going to call negative y motion. And just like that, I do have a coordinate system. I have an origin right here. At home, I'm calling this the origin of my coordinate system, which means it gets an ordered pair of 0, 0. And now I can define these other places in terms of this coordinate system also. Over here, the hospital, that's 4 miles in the y direction. So its x coordinate, because x comes first, its x coordinate is 0. Its y coordinate, I am 4 miles north, so 4 miles. The grocery store is 3 miles directly west of home. Its x coordinate is 3 miles away, but it's to the west, so it's negative 3 miles. Its y coordinate, I haven't traveled north or south, that's 0. And then the high school. To get to the high school, I had to go a half mile east, so 0.5 miles in the positive direction for x, because I'm going eastward, and then 1 mile south, so negative 1 mile for the y direction, because I'm traveling south. That's my coordinate system. Next, quantities in physics, at least in physics 1 and 2, tend to fall into two major categories. We have scalars and we have vectors. I'm going to do vectors first. A vector is a quantity that has a magnitude and a direction. So vectors need magnitude and direction both. We generally write vectors with this kind of a symbol. We write a letter and then we draw this vector hat over top. I wrote a V just because the word vector, it doesn't have to be a V. D, X, whatever, F. It can just be any old quantity, but it has a vector hat over the top. That's what that's called. A vector has a magnitude and a direction, I told you that. Going back to my coordinate system, one type of vector that I could provide is a displacement vector. So I'm going to go back to this thing. I'm going to go ahead and erase some of these items because I now have my coordinate system. I don't need to give all of these measurements anymore. Displacement tells me where I am relative to where I started. If I started from home and I went to the grocery store, my displacement, so I'm going to start from home and I'm going to go to the grocery store. My displacement is a vector that points from where I started to where I ended. And my displacement is going to be negative 3 miles in the x direction. If I really want, I can say plus 0 in the y direction, but I don't really need to include that. This is a vector because it tells you not just how far I went, but also in which direction. If I go from the grocery store to the hospital, let me grab a different color. From the grocery store to the hospital, I will need to go 3 miles east, 4 miles north. My displacement is from my starting point to my ending point. So if I want that displacement, I'm saying from the grocery store to where I end up, that displacement is going to be 3 miles in the positive x direction, 4 miles in the positive y direction. It gives me how far I'm going along the x-axis, how far I'm going along the y-axis. I could also say maybe I am flying a helicopter and I am passing right over the grocery store. I'm going to not take these roads, I'm just going to fly straight through. In that case, I could tell you how long this diagonal is, and I could tell you the angle inside this triangle. We'll get around to that a little bit later. I'm going to have to figure out just how I'm going to do that, just how to find that direction and the diagonal. That's a problem for a different day. I'm just right now telling you that's another option for how I might express a vector. I'm not limited to displacements either. I can say maybe I'm driving a car 45 miles an hour and I'm driving eastward on 6 Mile. Now I'm giving you a velocity. I've told you how fast I'm moving, that's the magnitude part of it, and in which direction, eastward. Those are vectors. Last piece, scalars. Scalars give a magnitude without giving a direction. I can tell you that the park is 2 miles from home. Going back to my coordinate system, I can tell you the park is 2 miles from home, but that doesn't give you a ton of information. The park being 2 miles from home, that just means it is somewhere on that circle. I can't tell you just where. I just know it's 2 miles away. It could be in any of those spots. It does give you a decent idea of how long it's going to take you to get there, but it doesn't tell you how to get there. This would be a measure of distance instead of displacement. I can tell you that you're walking at 2 meters per second, but not tell you where it is you're going. That's an example of speed instead of velocity. The magnitude of the vector is necessarily a scalar. Those aren't all the scalars though. So if I put my dog on a scale and he has a mass of 34 kilograms, there's not a direction that's even possible to associate with that. He's not 34 kilograms to the right or something. It doesn't make sense. So a magnitude doesn't have to have a possibility of a direction to go with it. But if it is a magnitude without a direction, we do have a scalar. There are lots of examples of vectors and scalars. Here are a few. Scalars, mass is a good one. Time, distance, speed, energy. These are good examples of scalars. For vectors, we might have force, momentum, displacement, velocity, acceleration. We have plenty of examples of each, and we'll do more along the way. So right now, it's just good to have the categories set up. We can add more to those buckets as we go. That's it for scalars, vectors, and coordinate systems.